Hello, welcome to the Be Formless Flow Driven CEO podcast. I have from Austin, Texas, Dave DeCaprio. Welcome to the show, Dave.
Thanks. Good to be here.
Yeah, thank you. It's Thursday afternoon, Friday morning here, so getting the kind of end of the week vibes happening. You said you've had an interesting week. I forgot to say there's a big supermoon this week as well, so it's one of the big ones. I don't know if you're into the moons, but yeah, so I think it's probably been a bit of a week for everybody. I can't remember what.
I did drive. I was driving home last night and we kind of go up a hill and I noticed like right at the top of the I was on the road going up to the top of the hill and the moon was just massive right up at the end.
Yeah,
Well,
yeah,
very obvious.
it's the bee. It's the beaver moon. Whatever, look that up. Whatever that means. But we don't have beavers in
Oh.
Australia, so. But anyway, we're not here to talk about that. We're here to talk about your journey, your story, and you're the president and COO, Chief Operating Officer at Firefly Neuroscience. When your
Yep.
your profile came up, I was super intrigued and I was super keen to chat to you. Just that Firefly Neuroscience. I was like, yes, we need to chat. And essentially, you lead product and operations for a brain health technology company, which is focused on turning neuro data into clearer clinical decision support. And your career spans analytics, data platforms, and health innovation. You bring a pragmatic lens to building tools clinicians will actually use because it's always that big neuroscience, and then what do you do with it? Like, and it sounds
Yep.
like you've put it into practical tools. And I was saying to pre-show, I have studied in neuroscience, and that was always one of my big things. Okay, so how do we then apply it to day to day? So it's
Right.
understood the brain and how it can work. And I love to get all your thoughts on it. I also want to acknowledge that when you booked in for the podcast and I asked you what's one unique insight you'd like to share in life, leadership, and or business, I loved this bit too. And you said pursue ideas that you will be proud of being involved with, even if they fail. So, Dave,
Yep.
over to you. Tell us how you came to Firefly Neuroscience. Have you always been interested in it? Yeah, and then obviously the answer to my question when booking in.
Yeah, there's a bunch there. So neuroscience is actually new for me. So I haven't been in it in that long. I've been at Firefly for about 6 months.
Oh wow.
Um, and yeah, and this was my, first real foray into neuroscience. I've been in healthcare and AI and data for 20 plus years.
Yeah, right.
So really, kind of started in that space like 20 years ago on the Human Genome Project. So I was like part of that at MIT, and that was very exciting to
Wow.
be in. Yeah, and it was really, you know, uh, being part of that just at that stage, I think was it's interesting because I didn't think when I was doing it that 20 years ago, that's what I would be talking about as the beginning of a new thing. But it was very pivotal time for me, sort of seeing what it was like for that kind of science to happen. And at that time, the big focus was cancer.
Yeah.
And the big thing we started to do was realize that we could characterize cancers different ways. It used to be that you would call it cancer based on how it looked under the microscope. And so there'd be like kidney cancer and pancreatic cancer and all this. With the Genome Project, it totally changed, and we started looking at the mutations in the genome that caused the
Yeah.
cancer. And so it was like we went from how it looked to what actually caused it. And the reason I bring all that up is because, and that was a long process, and now there are tons of really novel, interesting therapies for cancer and all kinds of things we can do. But it really came back to like just measuring things at the beginning.
Yeah.
And I think one of the interesting things that drew me to neuroscience and drew me to Firefly was really feeling like brain health and just the cognitive space in general was the next big area for medicine and science. That's what you know. I I've got aging parents, and I'm not as worried about their cancer and cardiovascular health. They've been taking care of that for a while, but you're worried about their mental health and,
Yeah.
potential cognitive decline. And I think, that's very common these days. And so that's going to be the big challenge for medicine. And I saw with cancer that it started with better measurement and better data and starting to learn about these diseases better. And so kind of just trying to apply that over. And when I jumped into neuro, that was kind of the area that got me interested was, hey, how do we start to learn from all this data and collect data about what's going on, just so we know better what's going on.
Yeah.
That
Fascinating.
was, yeah, yeah. So that's kind of how I ended up here. It's uh, and trying to make go into that other space of the do things that you only want to. What was it? Pursue ideas that you'd be proud of even if they fail, I think is the way I phrased it. Um, I do think that's important. And it actually came from I've been mainly in healthcare for the last 20 years. I have done a few other things. I ran a hedge fund for a while, and
Wow.
it was yeah, it was automated trading and using AI to like predict the markets and all that kind of stuff. Um, and then, it was like many things in that space. It sort of worked for a while until it didn't work anymore. And that's kind of the nature of every algorithm in trading. It's a very competitive market. Uh, and I realized after doing it for a few years that like it was only fun on the days when it worked. Um, I was like, I like doing this when it works, but if it doesn't work, I don't really want to do it.
Yeah, 100%.
And the problem of, pursuing aggressive ideas or trying to make a change is that like you don't win every day.
No.
Um, there are a lot, when you're trying to get a business off the ground or you're trying to do something entrepreneurial, there are a lot of days when things don't look great. Um, and if you can't find the motivation on those days to go still chase after that idea, then you're going to be in a lot of trouble. If you
Yeah.
can only do it on the days when it's good, you're not going to be successful. So that's, coming out of that, I realized like with the hedge fund, it was fun on the days when it was good, but on the days when it wasn't good, I didn't want to
Hated
be
it.
involved.
Yeah.
I was like, okay, like I need to do something where I can get my motivation on the days when it's not good, because that's the days when you know most need to be able to draw on your
I could not
motivation.
agree more. Yeah. Yeah.
And so, and that's what happened in healthcare when I'm in healthcare and I'm trying to solve a problem in brain health. Well, if this idea doesn't work, that's okay. Now we know that idea doesn't work, and I'm still happy we tried that. We've got one thing crossed off the list. We can try to figure something else out. I can get excited about um, I can get excited about the ideas I'm pursuing. Even if they don't work, then I know I can just go to another one. Um, and so, that allows me to bring the energy you need to bring every single day.
Yeah, it's interesting. Oh my God, there's so much to unpack here because,
Yeah,
like, let's start with, I got to remember all of this. I did say to you, I bank questions, but you mentioned, in the Genome project that you worked on 20 odd years ago, that you were
yeah,
using AI. I think a lot of people don't realize what they don't realize is that AI has been around since the 1950s. And yet, all of a sudden, this year in particular, it's like, oh, here it is. Wow, it's brand new. And it's like, well, no, it actually isn't that brand new. I mean, it was called what, machine intelligence, I think. But yeah, when I did my training in AI back in 2023, I was quite just like shocked. But it's like fascinating because you were playing with it and using it in 20 odd years ago. My first question is, has it fundamentally changed from what you've seen, what you were playing with or using, I should say, 20 years ago to now and what you can do now? I'm sure it has, but how significantly has it evolved?
yeah. It's tremendous. Yeah, when I started, we just called it pattern detection. It wasn't even machine learning back then. We
Oh,
used to,
okay.
and it's funny because back, in the early 2000s, like AI was a bad word. You didn't want to say AI because that that brought up images of a whole bunch of failures and overblown claims and things people had been saying. So you didn't want to call it AI. It was pattern detection. And then machine learning came out. And a lot of these were the same techniques that we got better and better at. Um, and so the names have shifted, but I think there have been some very fundamental shifts, especially in the last few years. The ability to, one of the things is a lot of the core algorithms underneath and the way everything worked, like that core math really has been around for a while and has been worked on and has been kind of an incremental revolution. But the ability of these models to sort of work with language and the ability for language to be able to solve a whole ton of different problems. And that was kind of, I think, the magic that happened in 2022 that made it work is um, the fact that if you just had a system that could figure out what the next logical thing to say was based on what the previous text, it turns out that that is able to be useful for solving a whole lot of problems. And I don't like, I'm not one for like, is it really thinking? Is it intelligent? I don't know, but like, it's useful. I know that.
Yeah.
Um, and and I think that really changed it where the shift in the last few years is that you don't have to understand all the algorithms and all the math and all the technology underneath in order to be able to use and get value out of these systems. And so that was always something we wanted to do, but it was very hard to do before we had language as the interface.
Yeah, amazing. And then neuroscience, right? Like, it is complex. Neuroscience, I won't lie, like, understanding all the kind of nuances around what constitutes neuroscience. And I'd love for you to potentially explain it a little bit more. But the ability to be able to, use it and take the data and be able to then create the practical tools, if you like, for clinicians when it comes to brain health. You mentioned about cognitive load and aging, etc. We're in this world right now, right, where everything is just so intense. Like you could be just on 24/7 and you see all the stats around the damage of what social media is doing to our brains, lots of things. It's not just an older person's issue, really, is it? Because in terms of, and I'd love your thoughts on this, because cognitive decline is potentially, I've had a couple of other people on the show a while ago, which reminded me about, our conversation now in terms of we were talking about even, when you're a high flying CEO exec and you're stressed, you're causing almost like a bit of damage is the
Yeah.
wrong word, but you're causing your brain to have to work overtime, which can then, you have those, I get them at times where I have those little mini mind freezes or brain freezes where I can't remember what I was talking about.
Mhm.
Do you see that
Yeah.
do you see that as well in terms of what you're doing from how you're, like from a brain health perspective? Like, are you looking with the clinicians, is it older people that you're looking at, or is it across the board? How does it work? And I don't know if that's
Yeah. So
a good question.
yeah. So, we in particularly mainly focus on sort of the more clinical,
Yeah.
actual disorders and diseases, kind of a medical focus. But um, what you're talking about is, certainly real, and that there are measurable effects going on in our brains with some of these things. We're not using the tools always today to be able to measure those, but um, getting a better understanding of exactly what's going on and exactly what's happening, I think is going to be important. And hopefully we get better tools and better capabilities as we go forward to be able to monitor, not just the older generation and cognitive decline, but cognitive performance all the time. We know sleep affects things. We know, stress, chronic stress has all kinds of makes all kinds of changes. And the neuroscience is fundamentally hard because it is so interconnected. There are many causes, it's very hard to separate it out into individual diseases. Your heart is super important, just as, your brain is important. Your heart is a super important organ, but we can characterize it pretty cleanly.
Yeah.
Like, pumping, is it pumping well? How much blood is it moving? And if you can see that, okay, like my heart's doing well. But the number of things you would have to know your brain is ultimately doing really well, the number of things you would have to measure, all kinds of behavior, focus, your ability to regulate your systems. It's tied into everything, so it's hard to separate. And I think that's one of the challenges with neuroscience is how do you know a little bit about the brain without knowing everything?
Yeah.
Because it's so connected.
So then how do you distill it? Like, talk me through, how does it work with, like where you're turning neuro data into clearer clinical decision support? and bringing that pragmatic lens to building tools clinicians can actually use. How does it
Yeah. So
work in the business?
yeah, and so it starts with we have an ability to measure, so we can measure the electrical signals coming out of your brain. Our device is a cap that you put on, and it's an EEG. It's a technology that's actually been around for a
Yeah,
really long time, but traditionally used in epilepsy and sleep. Trying to find seizures, which are pretty easy to find. When all the electrical signals go crazy, that's a seizure. But we're trying to find much more subtle signals in there. The key there is it is if you were to just look at one EEG, it would be very hard to really pull any useful information out of it at all. Um, you have to get a bunch of them and start to correlate those to what what's happening. So it's about collecting a database of many, many people and then tracking what's happening with those people clinically and then being able to learn the patterns where we say, hey, when we look at somebody with Alzheimer's or with ADHD or with depression, they look systematically different than healthy people, healthy,
yeah,
normal people. And how do we and so now when we get a new EEG signal, we can sort of compare that. Does this look more like a normal or more like depression? And then start to get information out of that. So that's the core things we're trying to do. And it's really how do you collect the data and how do you label that data so you can then categorize things?
yeah, fascinating. And is that then understanding that, then the clinicians can then to work through what the program or the plan is for the patient. Is that right? Like in terms of they can see once you've shared the data, the patterns, exactly what's going on. Is that then their
Yep.
ability to then be able to go, all right, this is the treatment plan, this is what we need to be to
Yeah.
doing? Is that how it works?
Yeah. Yeah, and that's the goal. And the key is to get to, and we're very early in this. This is a new science. So,
Yeah.
um, but it's really about trying to find the very specific decisions you can make, the very specific decisions a clinician has to make, and then giving them some information to help with those. So, a good example is giving children stimulants for ADHD.
Yeah.
This is obviously a decision that as a parent you want to be pretty careful about. There's a lot of
Yeah.
stress associated
Yeah.
with that. Like you want your child to be given every opportunity and the best things possible. You also are probably not really excited about getting a prescription and putting your kids on some drug regularly. So one of the things we can do is as part of this, you can look, does this and a lot of times ADHD is brought up by maybe the child's parent or the child's teacher is saying, hey, they're acting out in class and, I think they might have ADHD and maybe we should medicate the kid. Um, with this technology, you can put on and say, hey, does this child have a brain signature that looks like the type of ADHD that is improved by stimulants? Or is it something else? And, and sometimes it can be, maybe this kid has a hearing problem and isn't really hearing what's going on in class. And so they can't understand the teacher. And so they're bored and now they're fidgety.
Yeah.
It's not ADHD, it's a hearing problem. But if all you're doing is observing the behavior, you see the fidgety kid and then you automatically fit ADHD. And when that works, it's great. But you don't want your kid on stimulants if that's not ultimately the problem. It doesn't help. It ultimately won't fix the issue. And now you have the negatives of putting that kid on the drug. So being able to get down to very specific clinical decisions like that and being able to make a decision on treatment plan A or treatment plan B. So and that doesn't come all at once. You've got to build up evidence for those. You've got to understand them. But that's the direction we're going.
Yeah, that's amazing because excuse me, I even read an article the other day about, ADHD and like you're talking about the various drugs, etc. And it's like ADHD is like AI at the moment, really, isn't it? It's everywhere, like every second person. And I'm not at all in any way, shape, or form taking the piss out of anyone with ADHD or anything like that. But you do question it. You do wonder, like, what is it? Like, how do we drill down into it to get to the root cause is what you're talking about here, and then have the best plan possible, not just generic, like generically just go, generically, even if I don't
Right.
know if that's a word, but do you know what I mean? Like not just generalize and go, oh yeah, we'll just put them on this, for example. It's fascinating. You also said new science, and even from what I've studied in neuroscience and flow science, it's a very new science, in terms of there's people that know a lot about it, but then there's a lot of people that don't know a lot about it. And you talked about new science, and you talked about mental health almost, well, it's the next big thing, right? Cancer's still
Right.
obviously it's been around forever and a day. Hopefully they find a cure, especially from someone who has a terminal father. And my mum had cancer a couple of years ago. It's a lot, and you do hope at some point there is a cure. But then there's this mental health epidemic where there's loneliness. There's so many different mental health things going
Right.
on, and not just loneliness, depression, all the different things. When you say new science, why do you call it new science? Is it because it is so untapped at this point in time, or is it because it's a new frontier? I'm just trying to get to that. Yeah.
Yeah, because it's new knowledge that will be generated. Because there are things we don't understand how they work today. When you go, if you go to the doctor today to look at your cardiovascular health, they have your blood pressure, they have your blood pressure, all kinds of blood, your cholesterol readings. There's many, many measurements they're taking to understand your body. And we know, hey, when this number gets out of whack, that's an early sign that something is wrong. Today, people go to a neurologist because they start forgetting where they put their keys. There's no test that people are running to say, hey, we're seeing this. And the result is with cardiovascular health, years before people are finding physical problems, years before you have a heart attack, you have blood tests that are going wrong, and we're trying to address and correct these problems very, very early. And I think that's where we need to get to with brain health, which is that years before somebody starts misplacing their keys or forgetting where they put stuff or having problems remembering names, we're identifying, hey, something's a little bit off here. Here are the things we can do to fix this or to improve upon the situation. And that's, you know, I wish we had the tools for the brain that we do for the cardiovascular system. If we did, we'd be in a much better place.
Yeah. Do you think we're like a long way off in having like all the tools like from a neuroscience perspective?
Um, yes, but I guess everybody's used to things happening super quickly now, and it's one of the problems with human health is um, these are diseases and conditions that unfold over long periods of time, uh, and so uh, there is it will take some time to develop these tools. But that doesn't mean there's not progress along the way and not useful things that happen along the way. And so I think that's what we're looking at is, hey, how do we want to move as fast as possible, finding things that work, but also recognize that you don't immediately jump to, hey, the drug that's magically going to fix everything when you don't even have a good way to characterize what's wrong. And so these are going to be steps, and they're going to take a while. Like the Human Genome Project completed or the first sequence was in 1999, and now 2025, we're seeing all kinds of novel cancer treatments
Yeah.
get developed. That's 25 years it took to go from like initial cancer to where we are today. But the leaps are huge, and they're life changing for many, many millions of people.
Yeah.
And so I think this stuff is going to take a while, but I also think it's going to be life changing for tens of millions or hundreds of millions of people.
Yeah, I love it. And because you were talking before about when you were in hedge fund, you said hedge fund, I'm pretty sure you said that. And you were talking about,
Yep.
and this is you probably going, where is she going with this? But you were talking about, um, excuse me, pursue ideas that will be you'll be proud of being involved with, even if they fail. And on the days when it's hard, if your energy is not there, or if you're not feeling the flow, if you're not feeling like, you're just like, I'm not feeling it, then that's almost like a sign to get out. Listening to you, in terms of hedge fund, what you're actually doing now, and being in the health tech, health innovation. you're fundamentally solving like first world problem, like real world problems, I should say. Like, so that's impact. Like that's genuine impact. I'm not suggesting hedge fund isn't, but it's a very different form of problem solving, compared to, so it feels like,
Yeah,
so purpose is everything, right? And having that purpose in terms of what you guys are doing at Firefly Neuroscience and the North Star, if you like, of this is where we're heading and this is new frontier, new world order. That
yeah,
is, for me, sounds like that's, it's exciting.
yeah. It's always one of the things I always have as a leader in a company. One of the kind of mantras I have is like, I never want to work somewhere where we feel like, hey, we need to like, hey, the whole company should go take off a day and go volunteer at a food bank or something so that we all feel good about what we're doing. And I'm like, I would like it if we all just felt good about what we're doing when we show up to work every day.
Yeah.
We're like, no, like the best thing we as a team can do for humanity is like do our jobs every day because that's actually going to make the biggest difference and improve people's lives the most. So I've always tried to angle to companies, and that's like one of my warning signs is like, if we all feel like we need to take a day off and go like do a company project where we're doing good for the world, then like we should question what we're doing the other 4 days of the week.
Yeah, it's a good
Um,
point. I love it. Tell me, as a leader, you've just raised this, but as a leader and I am calling it a new frontier because it is new science. What you're doing is super innovative.
yeah.
That requires a company and a culture to be very entrepreneurial, if you like, test and learn, fail fast. What do you look for in the business, in the teams, in terms of being in the fact that you knew and you, like you said, you've only been in the business yourself 6 months.
Yeah, I think it's interesting because there is a culture of experimentation that you have to have and like fail fast and try things, but you have to learn from those. You have to learn from the successes and learning from the failures. And so I think there's two parts to that culture. One is having that mindset, hey, I'm going to try things and we're going to experiment, but you know, one of the advantages working at the Genome Project, I work with sort of real scientists, biologists, and chemists, and they're very meticulous about writing down what they did in their lab notebook and documenting it and making sure because these experiments are expensive that they're running, and you don't want to be wasting time running the same experiment 5 times. And
No.
so there, to me, there's, getting that culture right is really about encouraging that experimentation, but also making sure there's the process and the discipline in place so that as you're doing those experiments, you're building up a body of knowledge and not just a trail of failed science fair projects. Because, in 2 years, you may have failed at 10 things, but if what you have out of that is a very good understanding of what works and what doesn't and learnings, that's great. If what you have is 10 failed projects, you might not have anything. So um, there's that combination of discipline and creativity that,
Yeah, I love
you
it.
know, I'm always I'm always trying to jump back and forth between those two sides,
Yeah,
and pull one or the other.
it's very cool. I've got two last questions for you, or maybe three.
Sure.
In terms of Firefly Neuroscience and obviously what you're focusing on in terms of, I brought up earlier around the state of the world, excuse me, burnout is huge, stress in corporate, etc. Do you see a point in time with regards to what you're doing and not necessarily Firefly Neuroscience, but in this brain health space that there will be a point in time that we will be able to understand better the impacts of stress, like you said, no sleep, the impacts of, burnout, social media, like tech, etc. Do you think there'll come a point in time where we'll be able to see the patterns to then be able to understand how to then think of it like not a clinician, but almost like whether it's a coach or an advisor to be able to say, all right, well, this is a plan we need to do to get you out of your brain operating from survival mode because if it continues this way, you could end up with some sort of, disease. Do you think that we're going to get to a point in time where we're looking at it
Absolutely.
that way as well?
Absolutely.
Yeah.
We'll absolutely get there. I think you can already, the best correlate I have of that is sleep. I think you've got tens, hundreds of millions of people wearing sleep trackers every day. And I'd say societally, the awareness of the importance of sleep in the last 10, 15 years has really improved. I think most executives probably get better sleep now than they did 15 years ago because they've realized that to do their job effectively, they do need to get some rest. That's probably something that's a shift that I've certainly seen in my career. I know I'm better at getting sleep now, and
Me too.
I think that's just directly a result of people measuring their sleep and seeing, oh man, my fitness tracker knows when I didn't sleep well, and those days I'm not really as effective as other days where I did get good sleep. And I
Yeah.
think if you give it not and that's anecdotal evidence, but it's also evidence that we get at scale, and so we're learning from that. And I think, that's the tip of the iceberg, and I think we will get better and better at that as
Amazing.
time goes on.
Amazing. Second last question. Your backdrop, you've got all these beautiful, I don't know what to call them. Is there anything I just love it. Like, is that like your, yeah.
It's a mix of things because it's uh I guess um I don't know, there's the Vogue system right there. So that's actually how our product gets shipped. It's a little case that everything comes in.
Hmm.
That picture is a drawing my daughter did of Alan Turing, who's a famous computer scientist who cracked the code in World War II. So it's not Donald Trump, even though it does kind of look like him
Yeah,
with the
that's
hair.
what to say.
Actually, Alan Turing. So I get that a lot. And it's funny because most of the rest of it was originally from my daughter's playroom. We had a wall in her playroom that had all this kind of crazy stuff. Um, and then we changed houses and she grew up and didn't want that, wasn't as excited. So I just used that as my
Love
back
it.
wall. That was designed. And then, yeah, the Tribune Man a little.
Yeah, it's very cool. It's very cool. I mean, I just think about my brain and like, look at me with all my little fingers, like,
Yeah.
Um, Dave, what would be one piece of advice? Let's kind of get in. Let's go back to brain health for a second and what you're doing. What would be one piece of advice you would give, whether it's a parent or an elderly person or someone who was just not sure there was something not right, but they just didn't know what to do when it came to behave their brain health, for example, and they were just getting like almost band-aid type like responses in terms of just like take this drug or do this or that. But they wanted to delve deeper to get to the root cause of exactly what's going on here. What would be one piece of advice you would give them?
Yeah, whew, that is difficult. I think um, one thing I would do is there's a book actually I'd recommend called The End of Alzheimer's uh, by Dale Bresnan, and that's really interesting book that kind of I think walks through it does two things. One is it walks through some very specific prescriptions and things you can do, and much of it comes down to uh, a lot of the things we know that improve cardiovascular health are also good for brain health, and those two things are very linked. And so, but he does actually give you a very good understanding of kind of what's going on. So I certainly think that book is very good and has a lot of very good strategies and things you can do to, hey, if you're seeing this kind of stuff, here are some things you can do and that actually can make a difference. And so he's a wonderful Stanford scientist who's been studying this for decades. So I won't try to replicate his
No,
advice, but I'd
I
say
love a book. I
go
love
read
a
that.
good book recommendation. And how do we find out more about Firefly Neuroscience? How do we find out more about you?
Look us up on the web. Firefly. We're actually on the NASDAQ AIFF. And yeah, I'm always available. Love to talk to people. So find me on LinkedIn, Dave DeCaprio.
Yeah,
Uh,
awesome.
me there.
Thank you, Dave. I've really enjoyed our conversation and love that you are in the new frontier. And I guess for me, it feels like the possibilities are endless, and it's only just the beginning of what we're going to see in terms of from a brain health perspective. And like you said, the how much we can change and support the world when brain health is a big topic, and it's going to only get bigger and bigger, isn't it? So
Yeah.
it's very exciting, and I wish you the utmost success in the new frontier. So thank you for coming on the show.
Thanks for having me on. It's been really fun. I've
Yeah,
enjoyed
no,
it.
thank you. Have a good evening.
All right. Thanks. You too.